Hi friends, welcome to KVR Maths Academy. In this video, let us discuss geometrical meaning of the zeros of a polynomial in 10th class Polynomials chapter. Right, in the previous video itself I have explained the whole concept of polynomials. If you watch that one, you can easily understand the whole concept of polynomials. So I'll provide the link in the description itself. Yes, let us go through this. Yeah. So before going to the topic, friends, please subscribe my YouTube channel. Those who are not subscribed yet. Yes, thank you. Yes. Let us see. Geometrical meaning of the zeros of a polynomial. First one is graphical representation of linear polynomial. Next, graphical representation of quadratic polynomial. Next, graphical representation of cubic polynomial. I will explain, right? Yes. First one is graphical representation of linear polynomial. Yes. Actually, what is the general form of the linear polynomial? Yes. P of x is equal to ax plus b, right? So according to the textbook, take one example. P of x is equal to 2x plus 3. So here P of x means take as y is equal to 2x plus 3. So this one we have to show in the graphical representation, right? Look here. So first, according to this, draw a table. Yeah, x first x value, next y, x comma y values we have to take. This is ordered pair, right? Yeah, suppose x is equal to, here x values, let us take -2, -1, 0, 1, 2. So first 0, negative numbers to take and positive numbers to take, right? Yeah, see, take x is equal to -2. Yeah, then y is equal to 2, -2 is a -4, -4 plus 3, yeah, -1. So ordered pair is -2 comma -1, right? Next, second, -1 take, -1 into 2, -2, -2 plus 3 plus 1. So this ordered pair is -1 comma 1. Next, 0 take, 0 2s are 0, 0 plus 3, 3. So 0 comma 3. Right, next one take, 1 2s are 2 plus 3, 5. So 1 comma 5, this is. Next another one, take 2, 2 2s are 4, 4 plus 3, 7. So this is 2 comma 7, right? Yes, this is the table. So x is equal to, I have taken -2, -1, 0, 1, 2. Then y values have come -1, 1, 3, 5, 7. Ordered pairs are -2, -1, -1, 1, 0, 3, 1, 5, 2, 7. Right. So using this data, draw the graph. So in the rough diagram itself on the board, I'll draw. Right. Yeah. See, first coordinate axis, draw the coordinate axis. Coordinate axis, this is x dash, next y dash, right? Yeah, here this is intersecting point is O, 0, 0. Here 1, 2, 3, 4, 5, 6, 7, up to 7 I have taken. Here also same, -1, -2, -3, -4, -5, -6, -7. Here also positive y axis only, 1, 2, 3, 4, 5, 6, 7. Here also -1, -2, -3, -4, -5, -6, -7. Right? So I have taken like this. Now see, first to plot these points. -2 comma -1. -2 comma -1, it belongs to which quadrant? Quadrant 3, no? So -2 comma -1, this one only, no? Yes, this is the point, that is -2 comma -1. Next, -1 comma 1. X-axis, on x-axis -1, on y-axis 1. -1 comma 1, this is, right? Yes, this is -1 comma 1. Next, third one is 0 comma 3. X is 0 and y is 3, right? This one. Next 1 comma 5. See 1 and 5, this one. 1 and 5. Next 2 comma 7. 2 comma 7, this one. Now join all these points, right? Yeah, with the scale we have to join, right? So look here. This intersects x-axis at this point, right? It intersects x-axis at this point. No, so this point is in the middle of -1 and -2. -1 and -2 is, that is, yes, this is 1.5. This is 1.5 minus 1.5. Understood? Minus 1.5, it is also can be written as minus 1.5 comma 0, this one. On x-axis only, no? On x-axis minus 1.5, this is 3 by 2, minus 3 by 2 comma 0. Minus 3 by 2 comma 0. No? So this intersects x-axis at this point. No, that's why the 0 value of the given polynomial is minus 3 by 2. The 0 value of the given polynomial is minus 3 by 2. Otherwise, here how to find 0 of the polynomial? See, 2x plus 3 is equal to take 0. 2x is equal to plus 3, transform this side, minus 3. So x is equal to minus 3 by 2. X is equal to minus 3 by 2. So where it is, this is the graph of linear polynomial. It is a straight line, isn't it? It is a straight line where it intersects the x-axis. Where it intersects the x-axis is called 0 of the polynomial, or 0 value of the given polynomial. Understood clearly? So it intersects at this point only. This is between 1 and minus 1 and minus 2, no? So that's why this is minus 3 by 2 comma 0. So by the proof also we got minus 3 by 2. So linear polynomials graph will always be straight line. Will always be straight line. So this is y is equal to 2x plus 3. Y is equal to 2x plus 3 graph. So this is the rough diagram. If you draw in a graph sheet, you will get correctly. Understood clearly? In the graph sheet itself, you have to write scale also. Scale also on x-axis. On x-axis, here suppose it is a x-axis, 1 centimeter is equal to 1 unit. On y-axis, 1 centimeter is also equal to 1 unit. I have taken like this. Understood clearly about this? So this is the graphical representation of the linear polynomial. Understood clearly? Next I will explain graphical representation of the quadratic polynomial. Graphical representation of the quadratic polynomial, right? Next, graphical representation of quadratic polynomial. Graphical representation of quadratic polynomial. Suppose I have taken p of x is equal to x square minus 3x minus 4. I have taken. This is a quadratic polynomial or not? Yes, exactly. Why? Because its degree is 2, no? So that's why it is in the form of quadratic polynomial. So for this p of x is equal to x square minus 3x minus 4, let us draw the graph. So first find the values of x and y, which means here y is equal to x square minus 3x minus 4 take, right? So x, y, next after that ordered pair x comma y, let us find. So first take any value for x, next y, next x comma y ordered pair, right? Yeah, see what we are taking. First x value, let us take minus 2. So before 0 2 values, after 0 2 values, let us take. So minus 2. So substitute minus 2 in here. So that is y is equal to minus 2 whole square minus 3 into minus 2 minus 4. How much this will be? 4 minus into minus plus 6 minus 4. So 4 get cancelled. This will be, answer is 6. So ordered pair is x coordinate is minus 2 and y coordinate is 6. Next take 2. Take minus 1. So substitute here y is equal to minus 1 whole square minus 3 into minus 1 minus 4. That is, this is 1 minus into minus plus 3 minus 4. So 1 plus 3, 4, 4 minus 4 is 0. So here y value is 0. So next x coordinate minus 1, then y coordinate is 0. Next take 0. Right? Yeah. So substitute here 0 square 0 minus 3 into 0 3 minus 4. 0 minus 4 is minus 4. Here x coordinate is 0, then my y coordinate is minus 4. Let us take 1. Now substitute here y is equal to 1 square minus 3 into 1 minus 4. That is 1 square means 1 minus 3 minus 4. Minus 3 minus 4 is, yeah, how much? Minus 7. 1 minus 7 is minus 6. Right, here this will be minus 6. 1 comma minus 6. Next take another value 2. Here 2. Y is equal to 2 square minus 3 into 2 minus 4. That is equal to 4 minus 6 minus 4. Minus 4 plus 4 get cancelled. This is minus 6. So if you substitute 2, you also will get minus 6 only. So 2 comma minus 6. So I think it has not cut the x-axis. Take another value. Suppose 4 take. 4 take. So if here 0 come means 0 or positive value y-axis, then only the line cuts the x-axis. Right? So 4 take. So y is equal to 4 square minus 3 into 4 minus 4. That is 4 square 16. 16 minus 12 minus 4. Yes, 16 minus 12 minus 4 is 0. Yes, this is 0. 4 comma 0. So take another value. 5 take. Yes, y is equal to 5 square minus 3 into 5 minus 4. 5 square is 25 minus 3 5 is 15 minus 4. 25 minus 19? Yeah, 6. 5 comma 6. 5 comma 6 has come, right? Understood? Yeah. Okay, now draw the graph. See, first I am drawing coordinate axis. Here vertical axis and horizontal axis. Right? Yeah. So this is x-axis. X dash. This is y-axis. Y dash. Right? Here these axis intersecting point is O. This is called origin, no? 0 comma 0. Yeah. Now plot the points. 1, 2, 3, 4, 5, 6. Up to 6 enough. So I am taking up to 7. Here also minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. Yes, positive y-axis. 1, 2, 3, 4, 5, 6, 7. Next negative y-axis. Minus 1. Minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. Right? Yeah, now plot the points. So first one is minus 2 comma 6. On x-axis minus 2, on y-axis 6. Minus 2 comma 6. This will be like this. Isn't it? This is only rough diagram. If you draw on the graph, you will get perfectly, right? Yeah. So next, second point is minus 1 comma 0. Minus 1 comma 0. So this is only na. So x-axis on x-axis x coordinate is minus 1. Y coordinate 0 means on the x-axis we have to plot the point, right? Yeah. Next one 0 comma minus 4. So x is 0, which means x-axis not there. Y minus 4. So where will you keep the point? Yeah, this one. Right. Next 1 comma minus 6. X-axis on 1. And this is minus 6. So this will be here. Next 2 comma minus 6. 2 is also equal to minus 6 only. So plot the point like this. Next 4 comma 0. X-axis is for x coordinate is 4 and y coordinate is 0. So where will you plot the point? Yeah, this one. Next 5 comma 6. See, 5 comma 6 is look here, this one. 5 and 6. Now join these points. See. So this is the graph of x square minus 3x minus 4. This is the graph of x square minus 3x minus 4. So here this is in the shape of u, no? This is in the shape of u. So this is called parabola shape. This is called parabola shape, right? Yeah. So here what are the zeros of this graph? From the graph let us find. So zeros means, yes, where it has intersect the x-axis, where the line intersect the x-axis, those only called zeros of the given polynomial. So here it intersect x-axis at -1 and 4 only. So -1, x is equal to -1 and 4 are the zeros of the given polynomial. From the graph we can clearly see. So this point is actually -1 comma 0 and this point is 4 comma 0. So x coordinates are -1 and 4 only na. So x is, that's why the zeros of the given polynomials is -1 and 4. The zeros of the given polynomial is -1 comma 4. Suppose if you find this is zeros of the given polynomial, see x square minus 3x minus 4 is equal to 0. 0 value means we have to equal to 0 only na. Yeah. So how can you write this one? 4 ones are 4. Factors of 4. This is minus 4x plus x. Minus 4x plus x is minus 3x only na. Minus 4 is equal to 0. So x, if you do x common, this will be x minus 4 plus 1 common means x minus 4 is equal to 0. So again x minus 4 do common, x minus 4 common means x plus 1 is the remainder. X minus 4 common. Here remaining part is x plus 1. So x minus 4 is equal to 0 or x is equal x plus 1 equal to 0. So x is equal to plus 4 or x is equal to minus 1. So you got it from the graph or not? Yes. So this graph has two zero values. What are those? -1 comma 4. Have you understood clearly? Yeah. Okay. Observe these graphs carefully. In case 1, case 2, case 3, case 1 2 graphs has given, case 2 2 graphs, and case 3 also 2 graphs has given. Look here. In case 1, the graph, this is called parabola, no? The parabola intersect the x-axis at a and a dash, right? A and a dash. So it's here in case 2, the parabola intersect the x-axis at only one point, that is A. So in case 3, the parabola is not contact with the x-axis. Not contact with x-axis. So from this, what can you say? Yes, here in these two cases, in this case, it cuts the x-axis at 2 points, no? So it has 2 zeros. Understood? It has this. In this case, this has 2 zeros, right? A and A dash. A and A dash. Next, in this case, it graph intersect the x-axis at only one point, na? So it has 1 0. It has 1 0. Understood? Next, in third case, here parabola does not contact with x-axis. That's why it has no 0. It has no 0. So that's why quadratic polynomial has 2 zeros, 1 0 or no zeros. A quadratic polynomial has 2 zeros, at most 2 zeros or 1 0 or no zeros. So maximum number of zeros for a quadratic polynomial is 2. Understood? Now maximum number of zeros for a quadratic polynomial is 2. Have you understood about this? Yes. Next, I'll explain the graphical representation of cubic polynomial. Right? Next, graphical representation of a cubic polynomial. Suppose p of x is equal to x cube minus 4x I have taken. X cube minus 4x. Suppose it is y is equal to x cube minus 4x. First, draw the table and find out coordinate pairs, right? Yeah. So here first x, next y, x comma y values. Take here after the 0, take 2 values. Before the 0, take 2 values. 1, 2, 3, 4, 5. This is suppose minus 2, minus 1, 0, 1, 2. Take minus 2, minus 1, 0, 1, 2 in the place of x. Now substitute y is equal to, first minus 2 take na, x is equal to minus 2 na, minus 2 whole cube minus 4 into minus 2. How much this will be? Minus 2 whole cube is? Yes, minus 8. Minus into minus plus 8. 4 2 is 8 only na. So this is 0. So this is y is equal, if x is equal to minus 2, y is equal to 0. So ordinate pair is minus 2 comma 0. Next here y is equal to minus 1, x is equal to minus 1 take. Y is equal to minus 1 whole cube minus 4 into minus 1. This is minus 1 whole cube is minus 1. Minus into minus plus 4. How much? Yeah, plus 3. So if you take x is equal to minus 1, you will get y is equal to 3. So this is minus 1 comma 3. Next substitute 0. 0 cube minus 4 into 0 is completely 0. 0 comma 0. Next one substitute y is equal to 1 cube minus 4 into 1. 1 cube is 1 minus 4. That is minus 3. So if you substitute 1, you will get minus 3. 1 comma minus 3. Next substitute in the place of x, that is equal to 2 cube minus 4 into 2. 2 cube is 8 minus 4 2 is 8, 0. So we will get 0, 2 comma 0. Understood? Yeah. So now with this point, draw a graph. Roughly I am drawing on the board. So later you may draw on the graph sheet, right? If you draw on the graph sheet, you will get correctly, isn't it? Yeah. So this is, I have drawn coordinate axis, x dash here, y dash. Y dash, they intersected the origin. This is shown by O, right? Yeah. First take the points 1, 2, 3, 4, 5. Here also 1, 2, 3, 4, 5. Minus 1, minus 2, minus 3, minus 4, minus 5. Next minus 1, minus 2, minus 3, minus 4 and minus 5, right? Yeah. Now plot the points. First one is minus 2 comma 0. X coordinate is minus 2 and y coordinate is 0. So y coordinate not there anything, no? So this point will occurs on the x-axis. So this is minus 2 comma 0. Next minus 1 comma 3. Minus 1 and y coordinate is 3, no? So keep here. Next 0 comma 0. So this is 0 comma 0. Next 1 comma minus 3. 1 comma minus 3. Here only, na? Yeah. Next 2 comma 0. 2 comma 0 is this one. Now join all these points. This one like this. Yes. Yes. Look here. This graph intersects the x-axis on 3 points. This graph intersects the x-axis at 3 points. So there, that is minus 2 comma 0, 0 comma 0, 2 comma 0. So x values are, x is equal to minus 2, 0 and 2. X is equal to minus 2, 0 and 2. So these values are zeros of the given polynomial x cube minus 4x. These values are the minus 2, 0, 2 are the values, 0 values of given polynomial x cube minus 4x. Have you understood clearly? Yes. Now observe these graphs carefully. Observe these graphs carefully. Look here, this is the graph of y is equal to x cube and this is the graph of y is equal to x cube minus x square. This is y is equal to x cube and this is y is equal to x cube minus x square, right? Yeah. Look here. So this graph intersect the x-axis at only one point, that is origin 0 comma 0, right? Next, this graph intersect the x-axis at 0, 0 and 1, 0. 0, 0 and 1, 0. So here, this graph, this y is equal to x cube has only 1, 0. Only 1, 0. Why? Because it intersects the graph, it intersects the x-axis only one point. At only one point. Here, this graph has 2 zeros. Why? Because this graph intersects the x-axis at 0, 0, 1, 0. Here, 1, 0. Here, this will be 1, 0. This will be 2 zeros. Right. Here, this will be 3 zeros or not? Yes, exactly 3 zeros. Here, this one, this one, this one. What I told you, how can you find zero values of the given polynomial in the graph itself? Yes, wherever the graph intersects the x-axis, wherever the graph intersects the x-axis, then only we can easily find zero values of the given polynomial. Here it intersects at 1 point, it is intersects at 2 points, it intersects at 3 points. So that's why it has 1 0, it has 2 zeros, it has 3 zeros. So finally we can conclude that a cubic polynomial has at most 3 zeros. A cubic polynomial has at most 3 zeros or 3 solutions. Here it will be 1 0 or 2 zeros or 3 zeros. Understood? In linear polynomial itself only 1 0. In quadratic polynomial maximum number of zeros are 2 only. Here cubic polynomial maximum number of zeros will be 3. Understood? So write down here linear polynomial. Linear polynomial means how many zeros? 1 0 only, maximum number of zeros are 1. Suppose this is quadratic. Quadratic polynomial has maximum number of 2 zeros. Next, cubic polynomial has maximum number of 3 zeros. Here its degree is 1, that's why it has 1 zeros. Its degree is 2, that's why it has 2 zeros. Its cubic polynomial's degree is 3, so that's why it has maximum number of 3 zeros. So from this, what can you generalize? Suppose a polynomial is there, nth degree polynomial is there, nth degree polynomial. So how many zeros will be there here? Nth degree polynomial. Yes, exactly n zeros, n number of zeros will be there. N number of zeros will be there for a nth degree polynomial. Understood? So suppose the degree of a polynomial is 10, then how many zeros will be? Yes, exactly 10 zeros. Right? So suppose the degree of, suppose 50th degree polynomial is there. How many zeros will be there to the 50th degree polynomial? Yes, exactly 50 zeros. Understood clearly? Yes. I hope you understand clearly about this graphical representation of polynomials. Next video onwards, I'll explain the problems in exercises. Right? Okay friends, if you like my video, please like and share. Don't forget to subscribe. Thank you very much.